Hello everyone, this is a video for lesson 1.7 out of your Algebra 2 book, and we will be talking about piecewise functions. And our goals for this lesson would be to evaluate piecewise functions. We're going to do that algebraically and graphically. Then we're going to describe the characteristics of a piecewise graph, and a few of you, the honor specifically, will be writing the equations of a piecewise graph. So before we get into anything too complicated, let's talk about what a piecewise graph looks like. So let's say that we have a certain situation. At the beginning of the day on Monday, your friend has $300 in her digital wallet. She sends and receives the following electronic payments through Sunday. $50 payment received on Wednesday, $150 payment sent on Thursday, and a $100 payment received on Saturday. Well, you've got a graph next to it, and as you can tell, this graph looks like it's a bunch of pieces of a linear function put together, but they all have different domains. Well, according to the graph, what is your friend's balance when x is equal to 2? Well, first of all, what does that even mean? So let's look at the graph. So x is equal to 2 would be right here, and that is so many days after Monday. So if this is Monday, one day would be Tuesday, and then the second day would be Wednesday. This would be Thursday, Friday, Saturday, and then Sunday. So it makes sense for this to be the last point on your graph. So let's go back to our original question. It says, what is x when it's equal to 2? Well, if you track up here where x is 2, it looks like I have a point here at 350. And if you look at your y-axis, that is how much money she's got in her account. So does that make sense that you would have $350 on Wednesday? Well, let's go back over here. It says Wednesday, she got an extra $50. So if you start with $300 and you add $50 to that, then you do have $350. So that part makes sense. Okay, what about when x is equal to 4? So 4 is Friday. So let's track back up here. Now on Friday, it says that she has $250 in her account. Let's see here. It says $150 payment sent on Thursday. So if you're going to pay, you're going to take away $150. So that means on Thursday you should have $200. There's no mention of anything happening on Friday that would make it go up $50. So something's wrong with that. We're going to talk about that in a second. All right, let's go ahead and make a note because I forgot to do that before. So on day 2, so on Wednesday, the graph specifically says that she has $350. Now that checks out. But when it's 4, that means it's Friday. And according to the graph, on Friday, she's got $250. That does not check out. All right, so we know that Friday shouldn't be $250. So the next question says, do the values match what we expect? No, it does not. So Friday should really only have $200 in it. So what's going on? So what we're going to do is we're going to create a graph that is going to be more accurate. I'm going to tell you right now, if you have, if you're going to pay and you're going to collect money, it's going to have a sudden jump to it. It's not going to have any slope to it. You're not going to have so much money increasing between Monday and Wednesday. There shouldn't be a slow decrease between Wednesday and Thursday. So let me show you what we're talking about. Now, obviously, we start with $300 in our account, so we're going to put a big point right here at 300. And I'm going to just make life easy. I'm going to say this is Tuesday, Wednesday, Thursday, Friday, Saturday, and then Sunday. Okay. So there's a $50 payment received on Wednesday. So according to this, her bank account does not change until Wednesday. So if I track up here right there. So I'm just gonna keep $300 on my account until Wednesday. She doesn't have $300 on Wednesday, so I've got something like a barrier. So I'm gonna put a hollow circle here to represent this jump. So if I have a payment of $50 on Wednesday, it's gonna jump up to $350, like immediately. So on Wednesday, I have a solid point at $350, and this is very typical piecewise function. So it's up to Wednesday, I have $300, then now I have $350. So what's the next event? So I have a $150 payment sent on Thursday. So it's gonna stay $350 until Thursday. So I'm going to show I've got a hollow point right here. And if I make a payment $150, that's going to drop to $200. So on Thursday, I'm going to have a solid dot at $200. It's going to stay like that until I have a $100 payment received on Saturday. So she's going to gain money on Saturday, but it's going to remain $200 until that day. So as soon as Saturday hits, it's going to bump up $100, and it looks like it's all of a sudden back at $300, and it's going to stay there until Sunday for the rest of the week because there are no more changes. So what's really neat about this piecewise function is that it has 4 separate pieces. This is the first piece, and it applies for Monday and Tuesday, but it stops just short of Wednesday. So as soon as Wednesday hits, it pops up to $350, and as soon as Thursday hits, it jumps down to $200. So it's $200 Thursday and Friday, and then on Saturday, we got some more money in the bank, and then it's $300 for the rest of the week. So that works for all of your piecewise functions. It's just like any function, just kind of cut up into different sections and put on a graph. So a piecewise function is just a function that has 2 or more equations. And you can see you have an example right here. You have one equation that's linear. You should have an idea of what that looks like. And it is right here. So you have the equation, and then you have it over here in graph form. And then you have this other piece, which is 2x plus 1, but it's right here. Now notice this second part right here. This is your domain. So let's write the word domain above that. That's going to tell you where your graph exists. So like right above where your graph exists Monday, Tuesday, Wednesday, Thursday, Friday, this particular graph is going to be on your x-axis. So this blue one only exists for x values that are smaller or equal to 0. And this graph exists for values that are greater than 0. And if you notice, it's not equal to 0 for the green section. So look at the green part right here. See how you've got a hollow point? That means it's not equal to it, and then this one is equal to. So if I asked you to evaluate this function where x is equal to 0, you would look at the blue section, not the green section. Let's talk about the domain and the range of each section. So the blue section is everything that is less than 0. So your domain is already in this section. So it's x is less than or equal to 0. And then the second part, it's going to be greater than 0. So this is the blue part, this is the green part. The range, on the other hand, so the range of the blue part, that starts down here at negative infinity and goes up to, what number is that? Negative 2. So I'm going to write this in interval notation because it's easier. So it'll be negative infinity up to negative 2. And then on the green section, your range starts at positive 1, does not include it, and then it goes up to positive infinity. So the maximum value is positive infinity. Now, I made a little mistake right here. If you look at this negative 2, see how that's a solid circle? I should have put a bracket on there. Okay, let's get to some math parts. Okay, in this next section, we will be evaluating from an equation. So if you look at your piecewise function here, I have two different parts. So if you want to use your highlighters, it helps me kind of figure out which part I will be using. So I have a yellow part and I have a blue part. And what it's going to do is it's going to ask you to figure out what the equation is equal to when x is equal to 3, when it's equal to 2, and when it's equal to -1. So what you have to do is you need to look at the domain and figure out which piece does each x belong to. So what I've done underneath, I've split it into 3 categories. So if x is equal to 3, does it belong in the yellow piece or the blue piece? So the yellow piece exists when x is less than 2. Well, where does the 3 belong? Not the first one. 3 is greater than or equal to 2. So it's going to exist in the blue piece. So I'm going to write down x minus 5. So you just replace the 3 and you wind up with -2. So if you plug in a positive 3, so f of 3, that's going to be equal to -2. All right, where does it belong when x is equal to positive 2? Well, this one's not equal to 2, but this one is equal to 2. So this one also belongs with the blue piece. So plug in a 2. 2 minus 5 is -3. So if you plug in a positive 2, you wind up with -3. The last one says -1. So -1 is less than 2, so it's going to belong in the yellow section this time. So I'm going to write down 3x plus 1 and replace -1 wherever there's an x. So if I graphed it, at -1, my y value would be -2. Okay, so I love this next section. We're going to evaluate from a graph. So you don't have to look at an equation, but you do need to find when x is equal to 2. So I'm going to track right here. This is where x is 2, but you need to find your actual function. So it looks like it's going to hit about right here. So if x is equal to 2, what is your y value going to be? And it looks like it's hitting at -2. That's all you've got to do. Just look at the graph, find your x value, and then write down your matching y value. Okay, same thing with this one. Let me change colors. It says evaluate when x is equal to 0. So this is 0 right here in the middle, but you've got, you have two options. Either you can go up or you can go down. You're only able to use the one where it is equal to 0. And if you've got a hollow circle here, that means not equal. So the one that is equal to 0 is here, and that means that y is equal to +2. This one is just a different way to write the notation for x is equal to -1. That's all it is. So let me change colors one more time. I'm going to find x is -1. Where is my graph? So I'm going to track it down to here. That means y is equal to -2. Now, if you're in honors, you do need to be able to write the piecewise function. So I'm going to color code this real quick. We're going to do the yellow one first, then we're going to do the blue one next. So the yellow one is a constant. So we're going to start out with f of x. You've got 2 pieces. So I'm going to put the yellow one here, and I'm going to put the blue one here. And then next to that, we are going to write the domain. So the yellow one is a constant, so that's going to wind up just being equal to a number. And what number is it? It's actually going to be -2. So that's where it is on the y-axis. Your blue one, on the other hand, is going to be in slope-intercept form. So you can look at it and you can figure out, let me write intercept form for you real quick. The slope is going down 1, 2 over 1. Down 2 over 1. So that means that your slope is -2, and then your intercept is at +2, so it'll be +2. All you have to do is clarify where your domain is. We're going to use inequality form for your piecewise functions. So where is your graph -2? It's going to be everything less than 0. So x has to be less than 0. And your blue one is everything greater than 0. But if you notice, one of them is equal, the other one is not. So the blue one has the solid circle on it. So you're going to put =2 on there. And that's it. That's all you got to do. Okay, so for this next part, we're actually going to type in this graph on Desmos. And I'm going to have you make a little sketch, and then we're going to talk about the domain, range, and the end behavior. So this is actually a really important skill. It's very easy. You just have to remember how to type in the domain. So if you look, you have two different pieces, which means that you will have an equation on two different lines. So we're going to type in -x minus 4. And if you look, it goes all the way across the graph. But a piecewise function only exists, specifically this one exists between or when x is less than 0. So how do you type this in? Put a little space. I don't even think you have to put the space in there, but you're going to do an open brace. That is right above your enter sign. And then all you have to do is just kind of copy down what is in your problem. So it says x is less than 0. Let me show you my keystrokes. There you go. So I'm going to type x, and either you can just click it on your keyboard or you can just do it on the screen here, less than 0. And look what happens. See what it just kind of cut it off. So it starts at -infinity and goes all the way up to 0, and then it just stops. One thing Desmos will not do, it will not show you the solid circle versus a hollow circle. So you need to understand when you graph this on your paper that this will have a hollow circle because it's not equal to. All right, let me go ahead and graph the second part. So click on line 2, hit X, open bracket or brace. And this time you want to do x is greater than or equal to 0. I'll show you where to do that. Click on your keyboard, greater than or equal to 0. And it's awesome. It actually only graphs starting at 0 and everything greater than that. So it's going to be on the right-hand side. So it looks like kind of a mismatched absolute value graph, but you've got the red piece and then you have the blue piece. So what we're going to do is just kind of make a mental note of where our important parts are, and I'm just going to copy that over to my notes. So I'm going to color code like I normally do. This is going to be the yellow section, and this will be the blue section. So the yellow section is the red on the Desmos, and it looks like it hits at -4 on the X and -4 on the Y. So I'm going to make a little note here, -4, -4. Remember, you have to figure out if this is going to be a hollow or a solid circle. This is going to be a hollow circle because it is not equal to, and it's going to go through and up like that. So this is my yellow line. And the blue one, it will have a solid because it's equal to 0, and it looks like I've got the slope of up 1 over 1. So solid circle here, and then I'm going to straight out just like that, and that is blue. So that's how you sketch your piecewise function. The domain is going to be just kind of a repeat here. So the yellow one is x less than 0, and the blue one is x is greater than or equal to 0. The range, on the other hand, the lowest point on here is going to be -4, but it does not include -4, and we're just going to go straight up. So that is our range. If you do them separately, the blue one is going to be a little bit shorter. It will include the 0, but we're just going to do the range of the whole entire function at once. End behavior, remember, you make sure that you have focus on your arrows only. Let's make a little note one more time on here. So arrows only. If you are approaching the left side, what is the arrow doing? The arrow is going up. And the right side the arrow is also going up. And that's it. And just let me know if you've got any questions.